This question also caused many issues in the exam in 2015. It's paper 2 and it's question 12. So pause the video if you want to have a look at it, and now is the opportunity to do so. Otherwise, I'm going to go through the question. So we have a cross section of a milk tank, and what the cross section is the end. We have a look at the shape. We have the radius is 1.2 meters. So I'm going to do a lot of sketches. You don't have to do these sketches. Well, you should do some sketches, and I will explain which ones you do need, but you do not need all of these. This is for demonstration. So we have M, L, O, and this line is a chord joining these, and I will mark the dimensions in red. So the radius is 1.2, so the radius, that is 1.2, and this is 1.2, so 1.2 meters and 1.2 meters. So both of them are the radius of 1.2, so we have that, and the width of the surface of this, I'll do this one in blue. So this is 1.8. And you're probably thinking, what does this information mean, and what do I do with all of this? Now, what we have to find is this. I'm using a lot of colours just so you don't get confused, because there's a lot of different dimensions in the question, a lot of different lengths. So it's this, and we will call this the depth is D. Now you see that the depth is made up of this 1.2, so it's made up of 1.2, and we're going to mark this in green, and we've got this distance. The chord ML is horizontal, so we can say that this is X, and the distance, or the depth, sorry, not the distance, the depth is equal to 1.2, the radius, plus this X. I'm going to do this again, and I'm going to not put as many dimensions in this one, but we'll do this again. It's M, L, O. Same information from the last one, and if we have this whole thing being 1.8, then we can say that half of that distance is 0.9, and because the line, or the perpendicular bisector, we call it, that's the perpendicular bisector of ML, that's vertical. The line going from O up to ML, marked by this X, is a purely vertical line. You can see then that because of the symmetry, you can say that the distance from this point, mark this in, this point to this point is going to be given by 0.9 meters. So that is 0.9 meters. Doing an even better sketch, we get 0.9 meters. We get 1.2 meters, and we have this as x. Now the line with the length x is a vertical line, the line of 0.9 meters. That's part of the chord, and this is the half of the chord. This is a perpendicular bisector to the chord, so this has to be a right angle. Now, you see that the 1.2 meters is the hypotenuse because it is opposite the right angle. So we use Pythagoras. C squared equals A squared plus B squared. And that is Pythagoras for right angles. So the hypotenuse is 1.2. So 1.2 squared equals, you can make A any of the shorter sides, but let's make X is the A, because C is the hypotenuse and A and B each are the shorter sides. So we can take 0.9 squared away from either side. So we get 1.2 squared minus 0.9 squared. And doing that on the calculator and taking the square root, so you're going to first of all find the square and square root it. So we get 0.7937. I'm going to keep all of those decimal places in, and the units are meters. So I will go back up to this. We have D is the depth, and it's equal to the radius plus x. So you see, so the depth is this, it's radius, and this is x. So it's radius plus x. So depth D equals 1.2 plus x. So that's 1.2. Again, you want to specify exactly what x is, what d is. Make it very clear. 7937. And that gives us 1.9937 meters. Does the question say anything about rounding? It doesn't. No, it doesn't. So I'm going to go with to 3 significant figures. So I'm going to put 3SF. We say D equals 1.99 meters, and that is the final answer with 4 marks. And we'll now look at how the SQA gave the marks out in this question. Let's take a look. So the first mark would be for this. So what they call Marshall facts is being able to construct the right angled triangle in the situation, because a lot of the questions that come up on Pythagoras are Pythagoras in disguise. And what I mean by that is, you wouldn't look at this question and automatically, within half a second, know to use Pythagoras. Like, even the best of students wouldn't be able to do that. But you need to know that you've got your chord, you've got your perpendicular bisector to the chord. You think, oh, it's symmetrical. I can find half of the length of the chord, plug that in, and use Pythagoras. So the first mark is for this. And usually you need to put this. You need to put the square in, or you need to write 90 degrees to make it abundantly clear to the marker that you know this is right angled. Because Pythagoras' theorem relies upon you knowing that this is right angled. The second mark is for this. So that is the second mark. The third mark is for this. What you also need to make sure that you don't do is you don't get your x squared and your x mixed up. So you see, I've found that. So what I've done is I've put these numbers into the calculator. I found the value of x squared and I've square rooted it, and I put x there, not x squared, because this is the square root of this. So that is 3 marks, and the last mark is knowing to add the radius and x together and to get this part. So that would be the 4 marks. Now, the notes section explains the common mistakes and answers that pupils give. So if you don't use a diagram, you run the risk of losing so many marks, highlighted by this. If you make a mistake within the question and you don't have a diagram, you risk the follow-through marks. And another common mistake was wrongly making the assumption of the angles being 45. And as you see, that's not the case, because all 3 sides are different. So logically, none of the angles can be 45 in that case. Or at least if one of them is right angled, the other 2 can't be 45, because if 2 angles were 45 and you had a right angle, then 2 sides would have to be the same, which is not the case. But I hope you found this useful. I'll show you this one last time. This is what we've done, and I hope you found it useful. Best of luck with the studying.